Well, good evening and welcome to class. I hope y'all had a wonderful weekend. Did y'all have a wonderful weekend?
Did you have a good weekend?
Nope.
I'm sorry.
Such is life.
It is.
Do it.
It is. Sadly.
Okay. I'm going to talk about Cisco Packet Tracer. And what's wrong with this to start off with? Right. What else is not? Where's the server supposed to be? Is it? See, the Eagle server is supposed to be connected to R1 because it's on the same domain as the R1, right? Or same subnet. So if I used this cool looking thing, right? Did that fix it? Auto selected the cable. PC1 is supposed to connect to what? The switch, right? Why am I orange? Says it's up. Why? I guess I scared off all the females in here, right? Well, Kristen was the only one, wasn't she? Didn't think much to scare one off. Why did it take it a minute to go from orange to green? Cody, you had real world experience with this. Why does it take a minute? Think about it. When you connect something in, why does it take it a minute to recognize it?
Authorize it.
No. Auto negotiation with a handshake. Hi, I'm Prof. Stokely. Todd? His switch failed.
Yep.
He doesn't like me. So I guess that goes with his grade. Hi, I'm Prof. Stokely, Jared.
Hi, Jared Johnson.
There you go. Now we've auto-negotiated. Okay? And that's how it goes. Now we're green on both ends. But am I done?
That's 100%. So.
Am I done? All I needed to do was connect the cables, right, to make sure everything functioned? Now, wasn't that cool? Now, how easy was that lab? Then why did I only get 5 of you to turn them in? Just kidding. Everyone turned it in. I just want to make everyone feel bad. Aren't I such a nice professor?
Yes.
All right. I don't want to save it. Now, let's look at this week's lab. What are we supposed to do? Have y'all looked at it yet?
Set up IP, gateway, DNS, and one more thing.
For Lab 2, you have to, on 1B, set up a default gateway, a DNS, assign fast Ethernet IP address, link it to S1 onto fast Ethernet 02 with the correct type and the subnet mask for that fast Ethernet port. Right? So, if I'm right here, where's 1B? We're going to make one, right? So, we come over here. We got us a generic computer here. What do I want to call this? 1 Bravo, right? 1 Bravo. There we go. Now, let me go to the desktop here. What did it say that I needed to do? Do what? If I'm looking at the topology, 1B needs to be what? So how do I set it? IP configuration, right? So 172, not 147, 172, 16.1 dot what? My subnet mask is going to be, so what's my default gateway then? Which one? 172, 16, 254? Are you sure? What's my DNS server? Are you sure?
Yes.
Okay. So let's see. If I connect this from here to here, what is it going to do? What's it doing? It's doing the handshake, right? Why do you think it represents between a green and an amber? Does anyone know besides Cody? Why are those colors the way you see them right there? Anyone know? Green and orange are the two colors, the LED colors you're going to see on a Cisco switch. Green means the port is good and it has connectivity on that port. Orange means it's auto-negotiating. If it's blinking, that means once you plug it in, it'll turn orange automatically. It's acknowledging that there's a link there. If it's a solid orange and not blinking, then you have a problem with that port. Okay? So everyone get on the assignment for the week? Is everyone going to get 100 on the assignment for the week? You better. Right?
Yes.
Y'all liking this class? Do I need to explain this anymore? Do we need to do another example? Cole's shaking his head yes. Okay. Now that you know what your homework is, let's come back here. All right. We're going to view PDUs. All right. How are you going to view a PDU? Well, let's see what it says. In the far bottom left right? Or, I'm sorry, lower right, you have the simulation. See where it changed from real time to simulation? There's the real time, here's the simulation. If I'm going to click on the desktop, or click on the PC, and in desktop mode, I can then come over to open a command prompt, right? I'm going to ping something. What's it doing? Already hit enter.
Yeah, because you're in simulation mode, so it's not going to load until you come back to your screen.
Now, we're simulating the packets. You see my ICMP in my ARP packet, right? Y'all can see how this is going to go through. So let's look at the ICMP packet. What is an ICMP packet going to do? It sends the echo request, okay? And the ARP is what resolves the server name to an IP address, address resolution protocol. Now I can come down here and I can hit the auto capture play as it sends it, okay? Notice that what is it doing? The data got sent back, right? ICMP is just sending it back and forth. That's all it's going to do. Now, let's see here, what does it say? Click OK when no more messages to display come up. Why is it pinging it? That's the third time it's pinged it, right? What's it? Oh, now we have this one, right? What did that do? We're just waiting for this event list for it to continue to do what it's going to do, sending the packets back and forth. Right? Is there any other? I don't see the OK button, do you? It's trying to see if there's any more. Then it'll tell you, no more. Okay. I just pulled it off of there. Now let's examine these. So we have to go to what? There we go. Now notice what it's doing. The ICMP starts on header 3, right? Or layer 3. You'll understand the OSI model, right? What it's going to do is it sends it and comes back. So it sends it down to 2. Come on. That's the packet they would send. Right? Here's my source. I'm 1.3, sending it to 1.2, giving him my information. Okay, now let's look at ARP. Layer 2. It's an Ethernet header. What does it do? What does ARP do? It takes your MAC address, transfers it to an IP address. All right. It constructs a request to the target IP address. It encapsulates it and puts it into Ethernet frame. That fast Ethernet port sends it out. Pretty simple, right? You'll see how this can come into handy so you can kind of understand how network flows really happen. Then the server gets the information. It finds the MAC address, decapsulates it from the PDU, realizes an ARP request, requests the target's IP address matches the port IP address, make sure it matches, and then it updates the ARP table so that it knows if there's a packet going to this address with this MAC address, it goes to this port. That's all it does. And that's what the inbound looks like and the outbound. What's the difference? The inbound gives information. The outbound gives some information, right? Just tells you where it's going, right? Now, from the server going back, at the PC, it gets this information back from the server saying, okay, I've now recognized your ARP request. Here's where you're going to be going. That's all it does. Goes back up the in layer. Y'all catching on? Kind of, sort of. ICMP opens up the traffic. ARP says, here's my MAC address. It goes to the server from the PC. Server says, okay, this MAC address, you're going out this port. Sends it back to the PC saying, here's your port that you're connected to and the IP address. PC says, thank you. Okay, PC starts the traffic again to validate that that's still the port that I'm coming in on. That I still have that open traffic. When you ping, that's exactly what you get. Make sense? Any questions? Have I thoroughly confused you? PC. Remember, we pinged the server, right? We said, hi, I'm Scott. I'm trying to get the attention of the server. When I ping it, I'm sending traffic saying, hey, I'm Scott, hey, I'm Scott, hey, I'm Scott. The server goes, hi, Scott. Here's your port. This is where we're going to converse. So Cole and I are in this tunnel and we're talking. That's the only traffic that is going to go in here. I don't care what everyone else is saying in here. I'm only going to listen to Cole. That's what that tunnel does. But it's not a tunnel. I'm just using that as an illustration. That's that communication line. Okay? He sends it back and says, your IP address is ... Here's your MAC address. This is what I've got in my table. Do you see me? Obviously, if you responded to my request to see you, right? It's like asking the girl out on a date. She's going to tell you yes or no. Hopefully. Unless she just totally ignores you. All right. Let's look at this one. And I don't want to worry about the transport layer. Okay, examining a device's default gateway. Why do we have to have a default gateway? Do what?
In order to communicate with other networks.
Right. We have to say where my traffic is going out of my network. Conversely, any time that I'm inside my network, I can communicate with anyone that's on my network. But if I want to go outside of my network, I have to do what? Have a gateway. All a gateway does is it sends route information between that and the next router to say, okay, here we are. So if I need any traffic coming out of my network is going to go to that first router, and that router is going to send it out to whoever else is connected to it. Does that make sense? Remember the old phone, the phone game? Like if I whispered something to Todd, by the time he comes back to Brent, it's going to be completely different. How many routers would have had to gone through to communicate that? Todd would have had to talk to Jared. Jared would have had to talk to Cameron. Cameron would have had to talk to Anthony. Anthony would talk to Kevin. Kevin talked to Aaron. Aaron talked to Jimmy. So forth and so on. It's a lot of connectivity issues, right? There's a lot of things that could happen during that time period to cause it to go down. So, why is it essential that we understand our default gateway? Otherwise, we're limited to our own network. Does it do us any good to communicate with it inside our own network? Only inside our own network? Well, I guess it would if you were just like a secure network. But you have to understand default gateways have a lot of things going on. Why would, in question 2 here, it says, use the ping command to verify connectivity 127.0.0.1. Is that going to work? It better. What's 127.0.0.1? What? Come on, y'all can talk a little louder. Loopback address. All that is an internal loopback address on your NIC card or your network interface device, so that it can say, okay, yes, I can talk. In this instance, if we pinged 127.0.0.0, would that do anything? No, because you're not going to have a host on it. For one, that's a network address. What about 127.10.1.1? It could. 127.255.255.255. Can you do anything on that? Why not? It's a broadcast address for the loopback subnet. So what about that one? Can you? Do what? Sure, if there's something on there. Why would you want to do, what's the difference between ipconfig and ipconfig all?
They're not the same.
Do what?
What you see,
What you see. What's the difference?
IP config is just the basic.
It tells you your network connectivity. The one that's getting all the network traffic. That's all it tells you. ipconfig all shows you all the information for all your ports or your network interface cards, virtual or otherwise. What about a hidden gateway address problem? We need to troubleshoot this. Third shift help desk Cisco engineer asked you for help from the help desk to help the help desk technician. He had a trouble ticket user on host A1 complaining that computer on host 11B 11b.example.com does not respond to pings. Technician verified the cables in the network settings on both computers, but nothing unusual was found. You check with the corporate engineer who reports R2 has been temporarily down, brought down for an upgrade. Nodding your head and understanding, you ask the technician to ping host B 172.16.11.2 from host A. The ping is successful. Then you ask the technician to ping the gateway 254.254. What's wrong? What's wrong? Hmm? What's wrong? So let's go in here. And I'm going to go into enable. I'm going to go into config T, which is the terminal, right? I'm going to go into interface, fast, 0, 0. And I'm going to do a no shutdown. What did I just do?
Turn the port back on. That's all.
Oh, heck yes. Now I bet if I come over here, from here, go to desktop, let's go to command prompt. I'm going to ping what? host-11b.example.com. Not doing anything, is it? No. Oh, that's good. Did it work? Why did it work? Because right here in the host table on R2, I said host-11b.example.com is 172.16.11.2. So if I'm pinging out from here, trying to get to here, I can ping with a direct IP address. It'll always go to that NIC. But if you're trying to resolve the DNS, you have to go through an ARP packet. Well, there's nothing here to read it. No server, no router when this was down. Where's it going to resolve it? Right? Unless you have a local host on here, the host file, that says that 11b.example.com is 11b, it's not going to resolve to it. So it has to come up to here, goes to here, it comes back to here, and it comes down to here. So A to the switch, to the router, back to the switch, down to B. Makes sense. Actually, your host file is up here where your DNS is, so it actually comes up here. Do. So 1A actually goes to Eagle server, then comes back down to 11B. But when this line was down, you couldn't get up here to resolve that DNS, could he? Kind of bad when you try to call your girlfriend and your phone line's down, right? You ain't gonna get very far. All right. Let's examine the route. What does netstat-r mean? Are y'all reading along? Netstat-R makes you look at the routing table. All right. So let's see. Let me bring up one. Let's go to desktop here. So if I netstat-R, there's my routing table. What does it say? Anything on this network with a mask of this goes to this gateway of 255.254 via the interface 172.16.1.1. That's all it says. Right? Now let's talk a little bit about the privilege mode. Privilege mode enabled. And password here was class. Now that I'm in the privilege mode, right? All I did was turn off the password. We're going to go in and we're going to look at, and I want to show, now that I'm in enabled mode, I'm going to show my IP route. What is this telling me? Anyone have a clue? It's telling me 10.10.10.4 is directly connected out of serial 00. So this serial line, I've got a 10.10.10.4. That's that device right there. This is 10.10.10.3 or 10.10.10.2. Actually, maybe 10.10.10.6 is what this is saying. And outside of this port, I have it directly connected through Fast Ethernet 0, the 172.16 network. That's all it's saying. Pretty simple, right? So when this is looking to get up here to Eagle Server, what does it got to do? It's got to come up to the switch, comes in here, so it says, okay, I'm looking for Eagle Server. Well, I don't know where Eagle Server is, so let me forward it on up to here. So it forwards it on up to here to ISP. ISP then has a 10.4 is directly connected, right? Which is your first usable network. So you have a 5 and a 6. Then it says, that was my direct connect. I can see the 172.16.0.0.0 via my .5. Does that make sense? Y'all with me? So R2 Central has an IP address .5. So ISP can see all these down here via R2. Now, this one, it says, I am a direct connect to 192.168.254 network through my fast Ethernet. So that's this line going into here. So when I said I need, my default gateway was the 192.168.254.254 for my default gateway, right? It was saying, it comes up to here, says, I don't know where 192 is, but let me forward it up to here to my fellow router, who then says, oh yeah, I know where it's at. It's right here. That's what IP route does. It's a map. It shows you how routers get from point A to point B. C's mean they are direct connect. S mean I can see them. All right? Now notice we have a lot of other codes out here. What is I? IGRP. We'll get to that a little bit later on, second half of this semester. RIP, Routing Information Protocol. We'll get to that right before spring break. If it's a mobile device, is it a Border Gateway Protocol, which you won't get in this class. EIGRP, we'll get to that in advanced routing. OSPF will get into advanced routing. An external EIGRP we'll get to in advanced routing. All the OSPFs we'll get to in advanced routing. The ISIS we're not going to deal with. But those are the different codes, so when you're looking at a routing table, you know where that traffic is going. Blink stairs. Bueller. Aaron, you look too relaxed, man. Everyone else is glazed over, and you're just like, yeah, man, I'm cool. All right. Now, how many of you looked over or did the research on the command lines like I asked you to? Kind of. Do what? You played with it? Yeah, we did plenty of pings and trace routes. ICMP traffic we already talked about. Subnet and router configuration. All right. Now this is where we're going to start having to have a little bit of fun. All right. Our objective is to get PC1 to talk to PC2. How are we going to do that? Well, we've been assigned the 192.168.1 network /24. You do remember what I said with the subnetting test, right? How many hosts that we have to support? Easy way to do this. Okay? Y'all with me? You can't use these. If I have 4 IP addresses, but I can't use my network and broadcast, how many do I have? 2 available. What about here? 6, 14, 30, 60, 126, right? 60. Okay, we've got to find 15 hosts. Well, is that going to give me 15 hosts? Nope, this one is, right? What about 30 hosts? Will that work? So we got 2 of these, right? So the LAN connected to router 1, LAN connected to router 2. If I'm using the 1.0, right? So I've got X, 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 and I'm coming here, I'm incrementing by 32s, right? Pretty simple. Then I've got a 224 as my mask. So what we've got to do, now that we have these multiple ones you've got to do, the first thing you're going to do is you can say, I've got a 192.168.1.0 network, right? My next network is my next network is a But Prof, why can't we use this? Cisco won't let you. For these. Real hard, you can use it. How many use the 192.168.1.1? I think we all do, right? We're on the 192.168.1.0 network. We can use that one, right? So our next network will start with that. It says the LAN link between R1 and R2 will require IP addresses at each end of the link. Which means what? We need 2. So you're going to have a 252. So if I'm going to do that to give me IP addresses for here, if I'm going to do a 252, I've got, what would be my next network? What? So I have .65, .66. Because 67 would be my broadcast, 68 would be my next network, right? So let's just play around and see what it does. All right. Over here, I'm going to configure IP configuration. 192.168.1.33. And my default gateway for this one be what? Right? Right? Did y'all see that? So that when I'm on here, enable config T. Now that I'm in there, I'm going to do an interface. Config T. Interface F00. Now I'm going to give it an IP address of 192.168.1.65. No. For that one, we did 33, so 34, 255, 255, 255.250 what? 224. And I'm going to do a no shutdown. Exit. And then I'm going to do a int serial 00. I'm going to do an IP of 192.168.1.65 on this one. Oh. Okay, interface serial 0, 0, 0. Then I'm going to do that. Add my I in front of it. I'm going to do a clock rate of 64,000. Clock rate 64,000. Thank you. Oh, I was only on the DCE. That's right. No shut. And then I'm going to exit. Now I'm going to come over here. I'm going to command line. I'm going to go enable config t int fast 0 0. And I'm going to do an IP address of 192.168.1. Let's see. That's probably 1.1, so 1.2. Let's just do 1.3. No shut. And then exit. Then I'm going to do a int of serial 0, 0, 0. I'm going to do an IP address of 192.168.1.66 with 255. Do a clock rate of 64,000. Do a no shut. But wait, why am I only at 36? Let's see what it says. My IPs are wrong according to it, but you see how it actually works? So if I was over here, and I wanted to ping 192.168.1. Well, actually I need to do 33 because 33 is that other host. I don't know why it's timing out. Wow. Destination host is unreachable, but it got there, didn't it? Pretty funny. Is there any questions? Just because Cisco doesn't like the IP addresses I used. But it works. Green lights all the way through. Connectivity all the way through. Does that necessarily mean anything? I got 42%. Let's see which ones did I get right. PC1, the default gateway is wrong. Its IP address is wrong. Just my IP addresses. Because it didn't like that, but. Oh, well, here's why. Second subnet, third subnet. Yeah, it wanted it on that second subnet. Like I was saying, it wanted it on the 32 network for the first one. Does that make sense? So when you see where it's asked for the second subnet, don't use the .0 network when you're doing packet tracers. No questions? Coolio.